Thank you for invitation and for allowing me to present our project and company. So we are Israeli startup company. We started in 2021, but our research based on many years of development of iron sieve sorbents, a few tens of years development of iron sieve sorbents based on manganese aluminum oxides, and similar to colleague from Finland was presenting, but we are on industrial scale of production. We are a team of about 40 people in Rehovot. This is academic city near Weizmann Institute, about 20 kilometers from Tel Aviv. We raised more than $20 million for funding of our research and development and production. So purpose of my presentation is currently we are applying and in process of evaluation European Innovation Council grant for localization in our technology and production in Europe, and we are looking for more European partners for geothermal brines and other research and development projects. We are planning to do it in year 26-27. So we are applying now for such a grant. So we are developing high lithium ion sieve sorbent, which is utilizing our own technology and patents and also proprietary composition. And here is how ion sieve sorbents works. And so you probably all audience and probably knows how ion exchange works. So I will not be going into details, but details more in production know-how, technology. So this is electric vehicles which are driving demand for lithium, and still electric vehicles growing and lithium and battery production, requirements growing, but still there is a future gap for production, and daily technology might contribute a lot in this in supply of lithium. So there are certain advantages of daily technology. It's applying for new alternative sources, which are not high concentration brine and not hard rock, reducing production time, increasing lithium recovery rate, operation expenses, and capital expenditure, land requirement, water, and energy. So this is obvious, and the question is how people are capable, or some companies or technology developers can bring this to the market. This is our novel sorbent. We have a higher capacity, which sometimes, for comparatively with aluminium absorption, we are more than 10 times higher. High rejection, impurity rejections. We have a high concentration of eluate, sorbent durability, and adaptable for different processes, for ion exchange processes. And also we have a competitive cost. This is a general process flow diagram, how our technology works. So we are passing brine through ion exchanger, and re-injection spent brines. Then we are making desorption with a low concentrated sulfuric or nitric acid. We're not using fluoric acid. And then we are making sedimentation or polishing eluate and acid neutralization, and then go into midstream and downstream products like carbonate or high concentrate. Comparatively with other technologies, our extra DLE brings many advantages, including the ecological advantages, low energy use and low water requirements. This is the applicability of our two different brine sources and brine processing methods. So we are working with the salt brines with a low concentration. Our main project is a Dead Sea. We are working from both sides, Israeli and Jordanian sides. The concentration of lithium, it's about 20 ppm. It is a high salinity lake, about 340 TDS, with high magnesium, high bromine. We also can work with the medium concentrated salars. We work with many projects in Argentina. We tried also some projects in Chile, and we have a lot of projects for oil and gas produced waters, also in Europe and United States. And geothermal brines. Geothermal brines is probably main subject of. I will focus on that in my later slides. So we're using different reactors, different dynamic reactors for our technology, and our sorbent with the different requirements of answering different requirements of projects from different brine processing methods. So this is execution for all daily companies and for all sorbent producers. One of the major issue is execution. So it is starting from in-house lab, piloting, engineering, and projects. So we, during this period of growth of our company, we selected we tested more than 100 different brines. We made a lot of experiments. We're constantly evaluating brines. And by the way, we are very interested to evaluate some medium concentrated brines, which are results of Brineries project in our laboratory. We are doing it for initial test, about 10, 20 liters. We are doing it free of charge. This is our policy. Also, we developed relations with the tier 1 engineering companies. We're developing with them project feasibility, scoping studies, and we succeeded to establish good relationship with them for different projects. And also project partners. This line of selected partners, also we have a European partners, the MOL group. We are doing with them some project. I don't want to disclose what is it, but we are working with them very effectively. And we hope that we have a partner for oil and gas produced water in the United States. We have a partner, Halliburton. This is one of the leading oil and gas service companies. And we are doing brines within Pennsylvania, in other places. And there is a very big potential for oil and gas produced waters in the United States. And also high salinity brines. So we have some partners for high salinity brines in the United States, for Great Salt Lake, and in Canada, for example, one of our partner, Lithium Bank, we're using our sorbent for Leduc formation. And geothermal brine. So I mentioned one of our partner for geothermal brine. It is a Turkish company, Zorlu Energy. They have extremely low concentration, and I will demonstrate some results which we achieved with them. So sorbent production. Sorbent production, we have a pilot production in Israel. It's industrial production, but the smaller scale, which is enough for supplying current stage of our development. But we are looking for expansion. Expansion in 2 sites. We're expanding in the United States, and also we're expanding in Europe. In Europe, we started contract manufacturing in Romania, and we are going to expand this. And from these purposes to localization European production, we are applying for European grant to provide our ion exchange sorbent to produce our exchange sorbent for European project on European ground. So our here you can see our few completed pilots. One is ongoing pilot with Dead Sea, where we have a reactor and container, and we are still processing, and we are achieving very good recovery rate and efficiency. And we also conducted in Utah this project with a high potash lithium intrepid. It is also in the United States, and Turkey in Zorlu. This we made geothermal pilot last year. From geothermal potential, in Europe, #1 geothermal producer is Turkey, and we have two And that's why we initially focused on work with them, in spite of having very low concentration comparatively to some Northern Rhine-Westphalia or some other projects. They have already operation. So this is they're pumping a lot of brines. So this is a map of Turkey geothermal. This is mainly located in Western Anatolia with an installed capacity 1.7 gigawatt, which is quite big. And geothermal industry is established industry in Turkey. Unfortunately, comparatively to other locations, the concentration of lithium in Turkey is very low. But this leveraging with the amount of brine which they are pumping and establishing of technology, maturity of technology. So in this slide you can see concentration, which is low and relatively low, but amount of brine significant, and amount of potential of lithium also significant. We made pilot in Kizildere geothermal field where we had a 3.5 ppm lithium. And this is a demonstration of our summer work activity in 2023. We achieved a good recovery rate, and we work a team of 3 people. We work and we conducted pilot. We processed few cubic meters of brine and recovered lithium carbonate in the lab. This is the results with the selectivity. We achieved concentration from 3.5 ppm. We increased concentration of eluate almost 200 times. We achieved 90% recovery from this brine, and also achieved a good rejection rate of all impurities, and produced industrial grade lithium carbonate with 95% purity in the lab. Thank you very much. That's all.